Hey guys, welcome to day 7 of our AP Stat Notes from home. As promised, I told you guys that this would be a shorter video that was just going to kind of look at something we did yesterday and kind of just look at it in the lens of like a review from something we've already seen. So, if you remember, we were kind of talking about this whole idea of sampling distribution. A lot of things are happening, but essentially, we have figured out that when you take a sample, that sample falls in something called our sampling distribution. All right. And that sampling distribution kind of gives us a hint as towards like how accurate our sample should be, as long as we know the like true values of the whole population. So right now we've been working with proportions, and we know that we are able to find the mean, the standard deviation, and then we have our sample information. So then we can see how well our sample matches with the mean and standard deviation of the whole sampling distribution. So, if you guys remember, this is the slide that we ended on in terms of work for this question in particular. And in this question, it mentioned a school that was trying to have the 18-year-old women at that school kind of self-report their weight and height and stuff so that they could calculate their BMI. And we were basically looking at, okay, in this random sample of 200 women, was their sample a whole bunch different than what we know the population to be? And in particular, looking at what percent of women are over the 25 BMI mark, which is kind of what defined them as being a higher health risk or overweight or whatever. Now, you can see here, remember we had found the mean to be 0.22. That came directly from the question. We use this formula right here to find our standard deviation. And we also found the proportion of our sample, which was the 0.155. Now, this slide is extremely messy and crazy, and I want to focus today on looking at z-score. So we're going to go ahead and just kind of pull the important information with us. All right. So up here at the top, you can see that we have the mean was the 0.22. That came from the 22% of women in the population reported to be 25 or higher. This right here was the standard deviation that we found using our formula. And down at the bottom, notice I have gone back to using the p hat symbol. And if you forgot what that means, remember, the hat tells us that this was a sample statistic, not a population parameter. So in this case, we use p hat because this is the proportion of our sample of 200 women. So how do we find a z-score and what is a z-score? So when we originally did this question, all we said is, hey, we know 2 standard deviations away is this far and this far. And we know that 95% fall within 2 standard deviations. So if you're outside of that, then you're pretty unusual. But what if we want to be more specific? We don't know how far outside of it the 0.155 was. It could be just outside of the 2 standard deviations, or it could be really, really far, like 3 or 4 standard deviations away. So we instead now can come back to looking at our z-score formula, which is going to tell us, remember, a z-score is how many standard deviations away your specific sample is from the population parameters, all right? So in this case, our z-score and the formula we use for that is x, which is your sample statistic, minus the mean, which is your population parameter, divided by the population standard deviation. All right. And that's going to tell us again how many standard deviations away from this original 22% we were. All right. So let's go ahead and start doing the work here. We know that our mean, or sorry, we need to start with the sample statistic, which is the 0.155. And we will subtract our population mean of the 0.22. And we will divide by our population standard deviation, which is the 0.029. Now remember, if you're plugging this in the calculator, you want to make sure to use parentheses on the top or do it in 2 steps. Otherwise, that 0.22 will be divided by the 0.029 and not the whole subtraction thing at the top. So make sure you either use parentheses in the calculator or do it in 2 steps. And when you do that accurately, you should get negative 2.029. 0.24138. All right. So what does this mean? It means that our sample proportion of 15.5% of women is 2 point almost 25 standard deviations below the mean. Now remember, uh, 2 would make you unusual, so we are beyond that. Also remember, the negative is what tells us we're below the mean instead of above it, all right? So don't forget that. Z-scores can be very helpful because it gives us more of an exact location of where the sample stands instead of just a general beyond this or not beyond this. So in this case, again, we would be 2.25 standard deviations below the mean of the 22% that are reporting at a BMI of 25 or higher. So that means that we are pretty uncommon, but we're not like super, super out of control, out there uncommon. Because remember, if we're outside of 3 standard deviations, then that's really, really crazy far. But in this case, we were just past the 2 mark, which does put us outside of the middle 95%. So still very rare, but not out of control rare. All right. So in this case, we would still probably say, yeah, the 0.155 is far enough away from the 22 that we would probably say the self-reporting was not a good choice. All right. So remember, this was just a review on how to work with z-scores, what they mean. Now we're going to go ahead and switch gears a bit and look a little bit more at the exact probability of a sample like this occurring using the normal curve. All right. So let's go ahead and switch gears and look at that. So you can see here that we have the normal curve that popped up, and it has labeled on it the 68, 95, 99.7 rule, also known as the empirical rule. All right, and it has the actual percents labeled on here, but if you notice, it's not exactly 68 point, or it says 68.27, so it's not exactly 68 or 95. These are the actual probabilities. Remember, the empirical rule is just like a estimate. It's about that much. So when we've been talking 68, 95, 99.7, those are not our exact percentages. These are, but who's going to take the time to memorize those? So they usually just stick with this idea of 68, 95, and 99.7. So what are we going to do with the normal curve in terms of this? Remember, this sample that we got, all right, is essentially one sample out of this whole sampling distribution on this normal curve. So because we know where it would be located on the normal curve, we actually just found out that the z-score was 2.25, so it probably is about right here, all right? Because that would be 1 standard deviation away, 2 standard deviation, and that's a little bit further. It might be a little bit more right here, but close enough. So this is where our sample is in terms of our curve, all right? Because we now have the ability in this class that we've done so much with the normal curve, we actually can find the exact probability of getting something like this sample. Now, here's the deal. Whenever you're looking at something like this, the exact probability of getting something rounded to 3 decimal points is always going to be near 0, just because it's so rare to get exactly one number. So instead, when we do things like this, we would say, hey, what's the chances we would get a probability that like 0.15 or anything lower than that? So we actually go ahead and check out 1.155 and anything lower than that on our curve. All right. So when we're going to do this, this will actually just be a normal CDF question on our calculator. Now, what would we be putting on our calculator here? Remember, we can find the exact probability of this sample occurring or any sample that would be even a lower chance of happening than this one by plugging in our calculator a normal CDF from the negative 9999 up to the 0.155, and it will give us the exact probability, like what's the chance that a sample like this would occur if this original information were true. All right. So how are we going to plug it in the calculator? Well, I'm going to go ahead and switch over to the calculator, and we can look directly at that. All right. So here's our calculator. We're going to go to the menu. We're going to go to, remember, how do we find normal PDF and CDF? We go to menu 5.5, which is probability, then distributions. All right. Then we can go ahead and go to normal CDF. Now remember, I told you the PDF is whenever its X value is just one number. And in this case, if we just looked at 0.155, it would be so small of a chance of happening that it would just not even be worth us looking at. So we do CDF, and we're going to go anything lower than 0.155 because all of that should have a smaller chance of happening than what we had. All right. So we're going to go from negative 9999, which remember it kind of defaults that as that. If not, you can always just put in negative 9999. And then we're going to go up to the 0.155 that we got for our sample. This is the proportion of women who reported at being a BMI of 25 or higher in our sample of 200 women from the school that self-reported. Then our mean, we already know, is 0.22, and we have said that we found our standard deviation to be 0.029. So we're able to plug that in, and we hit OK. And that's it. That's as simple as it is. There's our probability right there. And that tells us that there is only a 1% chance of getting a sample like this or worse. All right. So that means that if I went out and collected a sample of 200 girls, the fact that we got 0.155 should only happen 1% of the time. I mean, technically 1.25% of the time if you want to get stingy. But that's incredibly small. All right. So 1.25 would be our normal CDF answer. All right. So that's the percent chance that we would get this sample. Now, this all can be used as evidence to kind of talk about, hey, is this sample legit or not? Now that our AP test is going to be shifting towards just being an extended response question, it is more than likely going to be the case that they're going to give you one overarching question and ask you to attack it from multiple angles to kind of prove your case. So that's why we're looking back at review of some of the things we've done in the past. And in this case, what are we trying to show? We're trying to show that this sample of 200 women is rare enough that we would say it shouldn't have happened. We have now looked at 3 different ways of doing that, and we're going to cover 2 more in the upcoming chapters, okay? So the first way we looked at doing that was just by simply finding where was 2 standard deviations to the left and right of that, and we know that 95% of all people should fall within 2. So if it's outside of those kind of gates of being the 2 standard deviation gates, then that would make it pretty rare. The second thing we did is looked up the z-score for it specifically using our formula, and we found out that it was negative 2.25, was it? And in that case, that tells us that it was far enough away underneath the mean of our true value that we would be able to consider it unusual. And the last thing we just did is we used normal CDF to actually find the probability of getting a sample like this. And in this case, the probability was extremely low. There was only a 1.25% chance that a sample like this should occur if the 22% is the true mean. So this is a very rare situation. So I really hope that this was a nice review for you guys. We have now seen 3 ways of tackling the same problem. We will look up 2 more in the future weeks of looking at confidence intervals and hypothesis testing. But really, you need to start seeing how this whole course is going to start tying together of using different strategies to prove that something is either true or unusual or that something's false. And that's kind of the direction we're going in. So we're starting to use everything we've looked at all year and we're bringing it all together for these questions. So again, thanks for joining me today. I hope you guys are staying healthy, staying fit, and have a great week.